Good morning all. So today I will discuss some more questions related to projectile motion only. So already in the last class we discussed some 20 to 30 questions on projectile motion and some more model questions are there. See the first question here. A particle is moving with velocity v bar equal to k into y I cap plus x j cap. Some equation was given for velocity here. I will write here the equation, that is v bar equal to k into y I cap plus x j cap. Of course, where k is constant given. Now the question is the general equation for its path. So general equation in the sense we have to write the equation in terms of x and y only. Equation of the path means the distance along x-axis, how it is related to the distance along y-axis. So the relation between x and y you have to write. But here the equation is given for velocity v. V equal to k into y I cap plus x j cap. According to this, first of all, let me consider only the x component of velocity. What is the x component of velocity here? This is ky I cap is the x component of velocity. You can separately write here ky I cap plus kxj cap. This ky I cap, ky is said to be x component. So x component can be written as ky. And x component in the sense, x component of velocity in the sense, you can write it as dx by dt. So dx by dt can be written as ky. And now you can write y component of velocity. What is y component of velocity here? Kx only. So that can be taken kx. What is the y component of velocity? You can write that is dy by dt. So dy by dt can be written as kx only. Now, by solving these two particular equations, you have to write an equation or relation between y and x. And about the time t, nothing was given in the question, and also we have no need to calculate anything related to time. So, better I will write here equation 2 by equation 1. What is that? dy by dt by dy by dx by dt. What is dy by dt now? That is kx. By dx by dt is ky. K and k will get cancelled, and dt and dt will get cancelled. So finally you will have the equation dy by dx equal to x by y. By taking cross multiplication here, you will get y dy. Here you will get y dy equal to x dx. By integrating this equation on both sides. What is integration for y? Integration 5 for y will be y square by 2 plus constant something, because no limits are given here, so that simply we are written the constant. And integral x dx will be x square by 2 plus c. C means constant only. All these constants relations you can write again c only. Okay. Now here by taking LCM here, y square plus 2c. 2c also can be written as, it is also some constant only, by 2. X square plus 2c by 2. 2 and 2 will get cancelled. And of course here also 2c. And 2 and 2 will get cancelled here. And 2c and 2c will go to one particular side. And finally you should not write 0. That is again a constant only. So finally you can write the equation y square equal to x square plus constant. This is the relation between y and x. That constant may be anything. Okay. So based on the given relations and given limits, the constant value will change. So it was given, the velocity of particle was given in an equation. And now if you want to calculate, or if you want to write this velocity, or if you want to write an equation for its path, then first of all you have to consider x component of velocity and y component of velocity separately, and to eliminate the t, time t, you better write the second equation by first equation, then you will get an equation for dy by dx. By taking cross multiplication, you are getting y dy equal to x dx, and then by taking integration on both sides, finally you will get y square equal to x square plus c. This is the answer. Question number 2. Figure shown 4 parts of a kicked football. I think the third question the diagram was given. Okay. Ignoring the effects of air on the flight, rank the paths according to initial horizontal velocity component, highest first. So I think this is the question. This is the diagram only for the second question here. No, there is a separate diagram for the second question. I will draw here. I will draw here the question diagram for the second question. So let me consider this is x-axis and this one is y-axis. This is the first path given. And second path is given like this. Of course, let me consider all these are parabolic only. And third path will be like this. And fourth path is having much more range here. So all these were named as. This is the second path, third one, fourth one. This is the question given. Okay. Now, some particle was projected. Of course, air is neglected here. In 4 different cases, the particles are following the process shown in the figure. Now the question is, rank the paths according to initial horizontal velocity, highest first. Initial horizontal velocity is more for which one? They are asking. Okay. See here, for all the 4, which remains constant? Can you just mention here which remains constant for all the 4? One particular factor remains constant for all these 4. What is that? Anybody? Anybody on YouTube also you can chart quickly. Which factor remains constant? Zoom lo unnavallu, are you able to see the diagram? Please tell that. Deepti cheppamma matladu.
Maximum height.
Very good. Maximum height. Very good. Maximum height is same. What is the general formula for maximum height? U square sin square theta by 2z. That means u sin theta component is constant. H is constant, u is constant, g is constant. Okay, that means u sin theta remains constant only. No? Then, what they are asking, initial horizontal velocity they are asking. What is the formula for range? U square sin 2 theta by g. That means you can write it as 2 into u cos theta into u sin theta by g. We can write it for range. And from the above equation, since h is constant, u sin theta always remains constant only. No? U sin theta is constant, g is constant, 2 is constant. That means range depends on which factor? U cos theta only. No? Range is directly proportional to u cos theta. And is range same for all the paths? No. Range is different for different paths here. For in which case range is maximum? In 4th case only range is maximum. No? When range is maximum, horizontal component of velocity u cos theta is also maximum. So in 4th case, u cos theta is maximum. Next to 4th one, third. Next to 3rd one, second. Next to 2nd, first. In this way, the horizontal component of velocity decreases. Understand? No. The path of a projectile in the absence of air drag as shown in the figure, by dotted line. Okay. If the air resistance is not ignored, then which one of the path shown in the figure is appropriate for the projectiles? Okay. I'll let you once read the question clearly. The path of projectile in the absence of air drag. That means if air is neglected, air is not presented, in that case the path is shown by the which one dotted line. That means the path is shown by this particular third diagram. Okay, if the air resistance is not ignored, then what will happen to the this path? Which of these following paths will indicate the correct one? First of all, whenever air is presented, initially if it is the path of the projectile, if air is presented, definitely height will decrease only. No? It cannot reach that much of height if air is presented. So maximum height should definitely decrease. And also in the air presence, there is opposing force on horizontal also. Range also will decrease. Range should be decreased and also height should be decreased. Which graph indicates such one? Let me consider 1, 2, 3, 4 like this. 1, 2, 3, 4. Then which indicates the correct one?
Fourth one.
4 only. Very good. So in all these 4 cases, you observe that in which case maximum height decreases from the dotted line and also range decreases from the dotted line. Okay, in fourth case only it is both are less than this dotted line. So that answer is the fourth one. Particle is projected up from a point at an angle theta with the horizontal direction. It is very general case only, object projection. At any time t dash, if p is the linear momentum, at any time, after some time it is given, p is the linear momentum, y is the vertical displacement, x is the horizontal displacement. The graph among the following which does not represent the variation of kinetic energy of the particle. They are asking which does not represent about variation of kinetic energy. Some different graphs are given. All are not in the same manner. All are given for kinetic energy, first of all. All are given for kinetic energy here. Now, see here, what is the relation between kinetic energy and distance y? So, in projectile motion, what is the formula for kinetic energy? Generally it is k equal to half m u square. But while the body is moving up, what will happen? Here definitely the vertical velocity will decrease. No? Horizontal velocity remains same, but vertical velocity will decrease. So that you have to write only the, you can just mention the relation between kinetic energy and distance y. Okay, what the equation you can write for y? For y, what is the equation you can write? You can write v square minus u square by 2a. V square minus u is always same, of course, and v square minus u square by 2a you can write. Okay, then what is the equation for v square here then? At any particular condition, v square can be written as 2ay plus u square. So this is half m into, in this velocity square you can write initial velocity square, it is any velocity you can consider, plus 2ay. Okay. Now this is equal to half mu square plus half m into 2ay. 2 and 2 will get cancelled. N A y. A means g1. That is also constant here. Okay. No. Now the relation between kinetic energy and y can be taken as k is directly proportional to k equal to half mE square, which is initial kinetic energy, constant plus mg into y given. That means when y increases, it is given kinetic energy also should increase. But see here, while the particle is moving up, what will happen? Y increases, na? Height increases. Na? When height increases, what should happen here? Kinetic energy should increase. But see here, kinetic energy is decreased initially. Okay, it is the wrong one. Actually, the relation is like this. And again, this is the real graph for the relation between kinetic energy and y. But it was given in reverse order. So this is the wrong option. This is not the correct graph given. But they are asking, I think, wrong option only they are asking, which does not represent given. So it may be the correct answer. Also, we can verify the next answers. Okay. No. What is the second one? Relation between kinetic energy and time. Okay. What we can write for the relation between kinetic energy and time? Kinetic energy is again half mv square anywhere. And along with the time, how v changes, that is important here. What is the relation between v and u, v and t? V equal to u plus at. So in that particular case, half m into u plus at whole square. Okay, for this relation, if k, that means y equal to some constant plus some other constant into, that means a plus b something. You will get equation in terms of p and p square only. If you just expand this relation, then you will get an equation in terms of t and t square. That means in terms of x and x square. That always gives parabola only, no? So this is also parabola. Always there is only positive sign here. So that it is only parabola, and this is correct option. The relation between kinetic energy and time is here the correct option. And here also kinetic energy and x only. X means only the horizontal distance. Okay. In case of horizontal distance, it directly follows the same relation. And last one, in case of kinetic energy and p square. What is the general formula for kinetic energy? P square by 2m. That means it is directly proportional to p square only, no? If p square increases, k also directly increases. So this is also correct graph. These two indicate the correct graphs for the given relations, and here only it was reversed. So actually reverse idi ila undali, ila undi. So it is the wrong option, but according to the given question, this is the correct answer. Okay. Next question number. Horizontal range of projectile is maximum when the angle of projection is. Very much simple question. You answer that. What should be the angle of projection when range is maximum? Quickly.
45 degrees.
45 degrees only. Simple question. Next, question number 6. The bullet is fixed with, fired, I think, not fixed. A bullet is fired with a velocity u, making an angle 60 degrees with the horizontal plane. The horizontal component of velocity of the bullet when it reaches the maximum height. Wherever the particle is, wherever the bullet is, horizontal component of velocity always remains same only, no? Because horizontal motion is uniform motion. Whatever the initial horizontal velocity is there, at any point the same horizontal velocity maintains. What is the formula for horizontal velocity here? U cos theta only, no? That is in this particular question it is. u cos 60. U cos 60 in the sense u into cos 60 value will be 1 by 2. So this is u by 2. So everywhere the horizontal velocity is u by 2. And what about vertical velocity? Will it be same like this, u sin theta? No, vertical velocity changes while you are going to the height. When it is maximum height, vertical velocity becomes 0. But horizontal velocity always remains same. So the answer is u by 2. Next, four bodies P, Q, R and S are projected with equal velocities having angles of projection 15, 13, 30, 45 and 60 with the horizontal respectively. The body having shortest range is, see here, shortest range they are asking. First of all, which will have more range? In which case the range is maximum? Let me consider this is 15, 30, 45 and 60. In which case the range will be maximum at 45 only, na? And what will happen to the next case is this is 30 and this is 60. Both for 30 and 60, both are complementary angles. So that range will be decreased. It is less than 45 degrees. Inka paiki vellipote ituvaipu vaste inka it vachesam 15 ante. Then what will happen to range? Range will decrease only, na? That means in which case range will be very much less. For 15 degrees only. For which very much less value here. That means not less or more values from 45. From the angle 45. So till what extent the angles were there? Towards increasing and towards decreasing order also. In that way you have to see. In this particular case, at 15 degrees only, the range will be very much less. See the next question. Let me just refer the question, next one. A stone projected with velocity u at an angle theta with horizontal reaches a maximum height h. When it is projected with velocity u at an angle 90 minus theta with the horizontal, it reaches a maximum height h2. The relation between the horizontal range of the projectile h1 and h2. And you can just observe here that given two angles, one is theta and other is 90 minus theta. I think both are, what type of angles they are? Both are complementary angles. That means for both of them range is same only. Okay. Now, what is the formula for maximum height now in the first case? The formula for maximum height h1 is equal to, what is the general formula? U square sine theta square sin square theta plus u square sin square theta by 2z. And what about h2? U square, I think in both the cases u is same only, no? Then what about theta here? 90 minus theta by 2z. What is sine 90 minus theta? Cos theta. So that we can write it as u square cos square theta by 2z. One is h1 and the other is h2, and they are asking here the relation between h1 and h2 and also r. So to get the r value, the answer should be in terms of sine theta and cos theta or sine 2 theta like that. So that better I can take here h1 into h2. If you just multiply here, see here, u square whole square will be u power 4 sin square theta into cos square theta by 2g whole square. Now, to get sine 2 theta here, okay, now you better to take you can multiply with 4 and divide with 4. Then you will get here, this one you can write it as u power 4 into this 4 sine square theta cos square theta, you can write it as 2 sine theta cos theta whole square only, no? By 4 into 4g square. Then this will be u power 4 into 2 sine theta cos theta can be written as sine 2 theta, na? Sine 2 theta whole square by 16g square. Then we can just write this equation as u square whole square separately you can write sine 2 theta whole square. U square sine 2 theta whole square by 16 separate ga raste g square. Now what is u square sine 2 theta by g?
R.
This is nothing but range only, no? So that means you will get here u1 into u2 is equal to how much? Range square by 16. This is 1 by 16. This is range square by 16. What is h1 and h2? h1 into h2 is nothing but r square by 16. Then what is r square? 16 h1 h2. Then r, if you want to write by taking square root here, 4 root over h1 h2. That is the answer. Simply we have written the equations for h1 and h2 separately, and this will be multiplied to get the value of range. But directly we don't get the equation of range. So to convert it into the equation of range, just we multiply with 4 and divide it with 4, and finally we got the equation r equal to 4 root over h1 h2. Okay. Now, for a given velocity, the projectile has the same range r for two angles of projection. If T1 and T2 are the times of flight in the two cases, then they're asking here the relation between range and T1 and T2. What is the formula for total time of flight? What is the formula for time of flight?
2u sin theta by g.
Very good. 2u sin theta by g. And what is the formula for T2 then? Complementary angles, na? Both are complementary angles. Range is same in the sense complementary. 2u sin 90 minus theta, that is cos theta. So T1 is 2u sin theta by g, T2 is 2u cos theta by g. Okay. Now, to get the equation of range, better we multiply both of these. So what about T1, T2 then? 2 into 2, 4, u square sin theta cos theta by g square. This is equal to 4 లో 2 ఒకటే సపరేట్ చేద్దాం. ఎందుకంటే ఒక 2 ఇందులోకి వెళ్ళిపోతే 2 sin theta cos theta can be written as sin 2 theta by g into g. Why? Because what is u square sin 2 theta by g? Range only, na? So that you can write it as 2r by g. So T1 into T2 equal to 2r by g. So simply this is the final equation, and range is directly proportional to T1 into T2. This is the answer. Range is directly proportional to T1 into T2. Based on the known relation, just we have to try to get the relation for range only. Okay. Now, question number 10. A football is kicked off with an initial speed of 19.6 meter per second to have maximum range. Okay. Goalkeeper standing on the goal line 67.4 meter away in the direction of the kick starts running opposite to the direction of kick to meet the ball at that instant. What must his speed be if he is to catch the ball before it hits the ground? Okay, very good. See, all of you, please try to understand the question first. And all of you who are on YouTube, all of you, please mention your name now. ఇంతకుముందు చేసింది కాదు, ఇప్పుడు మళ్ళీ మీ పేరు మెన్షన్ చేసి లైవ్ చాట్లో పెట్టండి. ఎవరికైనా if you are not able to start on YouTube, you can just send me your name to your personal WhatsApp, name to my personal WhatsApp number. అందులో ఫస్ట్ నేమ్ నేను మెన్షన్ చేసేయండి. Okay, see this. For example, this is the point where the football is kicked here. Of course, when it is to have a maximum range in the sense, what is the angle of projection? 45 degrees. So then it will just fall somewhere here. Okay. Now, what is the formula for maximum range?
U square sine 2 theta by g.
General formula is U square sine 2 theta by g. Only maximum range we are asking. That means sine 2 theta becomes 1 only, no? So then it is U square by 0. U square in the sense 19.6 whole square. I will write here 19.6 into 19.6 by g is 9.8. 9.82 it is. 2 19.6 is how much? I think 13.2. That is the maximum range. But where the goalkeeper is or somebody is, goalkeeper is at what distance from the starting point the goalkeeper was? He was at 67.4. From here to here it is only 39.2 meters. The goalkeeper is at this point 67.4. Then what is the distance the goalkeeper has to travel to catch the ball here? That means 67.4 minus 39.2 only, no? What is 7.4 minus 39.2? I think 28.2. So this much distance the goalkeeper has to travel from here to here to catch the ball. Okay, so what time he should take? For what time the ball was in the air, the same time he should take. Okay, now what about the time taken for the whole motion? That is time of flight. What is the formula for time of flight? 2u sin theta by g. 2 into u in the sense 19.6. Sin theta means it was just thrown in such a way that the range is maximum, so that angular projection is 45 degrees. By g is 9.8. Again 9.820. This will be 2 into sin 45. Sin 45 is how much? 1 by root 2. So 2 into 2 by root 2, it will be 2 root 2. What is the time taken? 2 root 2 seconds. So to travel this much of distance, he should take the time of 2 root 2 seconds. That means what should be the speed of that person, goalkeeper? That is distance by time only, no? That is 28.2 by 2 root 2. 2 root 2 in the sense, I think all of you know the value of root 2. Root 2 is 1.414 something. Let me consider 1.41. 2 into 1.41 is
2.8.
2.82. 28.2 by 2.82. How much is the answer then? 10. So the speed of the goalkeeper should be how much? 10 meter per second only. Speed of the goalkeeper is 10 meter per second only. Let you understand. Here it was given that the ball is kicked from this particular point. It will reach in such a way that the range is maximum. That means it was projected with an angle 45 degrees. And velocity is also given. Then from this point at 67.4 meters, goalkeeper was here. Whenever this ball was kicked, the goalkeeper starts running in this particular direction. To catch the ball here, what should be the speed of the goalkeeper? That is the question. Now, first of all, we calculated range where it will be landed, and then we can know that for what distance he has to travel. And also the time of travel for the ball and the goalkeeper should be same only. So that we calculated time of flight here. The same time we used to calculate the speed of the goalkeeper also. Then just we got the answer, that is 10 meter per second. Next one. The ball is projected from the ground at a speed of 10 meter per second, making an angle of 30 degrees with the horizontal. Another ball is simultaneously released from point on the vertical line. Another ball is released from point on the vertical line along the maximum height of the projectile. Okay. Both the balls collide at the maximum height of first ball. Okay. The initial height of the second ball. Okay. Good question. So all of you please see the question there. See the question carefully. Read the question carefully. Two balls were given. And first ball is just projected with what velocity? 10 meter per second. At what angle? 30 degrees angle. It may follow the projectile motion like this. It was projected with 10 meter per second and angle will be 30 degrees. That is about the first ball. Another ball is simultaneously released from point on the vertical line along the maximum height of the projectile. Like this. Both the balls collide at the maximum height of the first ball. Here, the second ball was projected from some other point above this projectile motion along the maximum height line. Then whenever this particle comes here, this particle also comes here and both will be collided. That is given. And the question is, the initial height of second ball they are asking. What is the time taken for this ball to travel from here to here before collision? That is time of ascent only, no? Time of ascent for the first ball. What is the formula?
U sin theta by G. U sin theta by
U
G.
sin theta by G. What is U given? 10. Sin theta means sin 30 is half. By G means 10 you can consider. Then what is the time taken? Half second only, no? So the ball from here to here it will take half second. In the same half second, this body also should come here, no? It was released in the sense it is just like freely falling body. For freely falling body, what is the velocity? For freely falling body, what is the height traveled within half second? That you can simply write S equal to ut plus half at square. S means that you have to find out the height that travels. U means 0. Initially it was released only, so 0 plus half into acceleration is 10 and time is half second given, half whole square. Then it will be 10 into 1 by 4 into 1 by 8, 10 by 8. 10 by 8 means how much then? 10 by 8 will be how much? 1.25, I think. So, what is the question? The initial height of the second ball from this point to this point, it is how much? 1.25 meters. But the question is initial height of the second ball. And ikkada nunchi chudali height man. That means the maximum height of first ball also you should know here, na? What is the maximum height of first ball? Then you calculate it. U square is 100. Sin square theta means sin theta is half, na? Sin square theta 1 by 4 by 2z. That means 2 into 10. 2 into 10, 20 into 80. 20 into 4, 80. That means again it is 10 by 8, na? 5 by 4 only. This is also 1.25 meters, na? So this is also 1.25 meters. This is also 1.25 meters. Totally how much the distance is? 1.25 plus 1.25, 2.5 meters. And totally the height is 2.5 meters. Any more doubts? So let you understand this. First of all, you have to understand the question and situation clearly given in the question. Okay, then you have to imagine a rough diagram, how the particles are moving, what was the situation given in the question, and that information you make it ready, and finally what was the question and how to solve the procedure also you have to first see that. Then you have to start solve the problem. Then easily you can understand, easily you can get the answer. Okay. Now, question number 12. Let me read the question. The ball thrown by one player reaches the other in 2 seconds. The maximum height attained by the ball above the point of projection will be about. It was not given that how the ball was projected. Since we are dealing here only the projectile motion questions, so let me consider this is projectile motion only, oblique projectile motion only. What is the total time taken? You can consider 2 seconds. No? What is the total time formula? 2u sin theta by g. That can be taken as 2 seconds. I think it is not the complete question. Some information was not there, whether it is projectile, oblique projectile, or vertically projected motion, whatever it is, not given, but I just considered this is only the oblique projectile. Then 2u sin theta by g equal to 2. Next, then what is u sin theta? Of course, 2 and 2 will get cancelled. When g comes to other side, u sin theta is nothing but g only. No? U sin theta can be taken as g only. Of course, g is 10 only. And what they are asking here, the maximum height attained by the ball above the point of projection. Maximum height formula is h equal to u square sin square theta by g. What is u sin theta? Is g only. U square sin square theta means g square. G square by g only. G square by g is only g, na? So answer is g. That means answer is 10 meters. The maximum height can be taken as 10 meters. Okay. See the next question. And for the next Sunday, and in the last week, completely explained about the problems in motion in 1 dimension, and now it is motion in 2 dimensions. In case of motion in one dimension, I explained about velocity, displacement and acceleration problems, uniform accelerated motion, non-uniform accelerated motion, random motion, and now it is in two-dimensional motion. It is about projectile motion, and also we have horizontal projectiles and relative motion. Okay, the next two concepts like horizontal projectile motion, relative motion also I will complete in next 2 days. Okay, so then I will go through the other topics also. Whatever the topics I will cover before the next Sunday, before the coming Sunday. I think coming Sunday is 16th only. On 16th, all of you will have the examination on both physics and chemistry. There is a separate examination for first years and separate examination for second years. Okay. So on these particular topics of kinematics completely, you will have to attempt an examination on the next Sunday, that is 16th only. You just refer all these topics from your notes, from the material, and from other books also you can refer, and also you can see the videos, these videos for the explanation of questions, and also you can follow some assignments, and we have to write the examination on next Sunday. Okay. Please remember that and prepare all these questions properly from your material and notes also. Okay. See the question, which is the question 13th. The projectile is thrown in upward direction, making an angle of 60 degrees with the horizontal direction with velocity of 147 meters per second. Then the time after which is inclination with the horizontal is 45 degrees. Very, very, very important model question it is. Okay, see here. Initially the body was projected with an angle 45 degrees, sorry 60 degrees. So and later on while it is moving, the angle reaches to 0. At one particular position, angle may become 45 degrees also. I will just draw the diagram here. If it is projected at an angle 60 degrees like this, while the particle is moving like this, angle will change here. Here angle will be less only. That may be 45. So when the particle is here or here, in both cases, which remains constant? Horizontal velocity is constant only, na? Let me consider the initial velocity here is u, here the velocity is v. So what is the horizontal velocity initially? U cos 60 degrees. And after some time, what is the horizontal velocity? V cos 45 degrees. And of course, both are same only. And always horizontal component of velocity is same. U is also given. What is given for u? 147. What is cos 60? Half only. V we don't know, that you have to calculate. And cos 45 will be how much?
1 by
1
root.
by root. Then 1 root 2 and root 2 will cancel here. So finally here V is equal to 147 by root 2. They're asking the same question only. Time they are asking. Time after which is inclination with the time taken to travel to that value they are asking. So U value we come to know, then V value also we know here. But they are asking here what is the time taken from this point to that point they are asking. Okay. Now only vertical components you take to calculate the time. Here what is the vertical component in first case? Initially u sin theta. That means 147 sin 60 degrees. How much? 147 into sin 60 is root 3 by 2. And what about vertical component after some time? We calculated that V 147 by root 2 into sin 45 will be 1 by root 2. That means 147 by 2. So this is initial vertical velocity. This is final vertical velocity. They are asking here to calculate the time taken to reach from this velocity to this velocity. Which formula we can use to calculate that? V equal to U plus AT. V is how much? 147 by 2. And U is initial velocity is only y components you have to consider. 147 root 3 by 2. While the particle is moving up, what is the acceleration? Minus g into t. So the t value only you have to find it. How will you calculate that now? 10t equal to ఇటువైపు వచ్చేస్తే 147/2 కామన్ తీసేస్తే into root 3 minus 1. Then you can just calculate the value. 147/2 into root 3 minus 1 will be how much? Root 3 is 1.73 minus 1 is 0.73. You just calculate this value for time now. You will get the answer there. Okay. Next. Question number 14. The velocity of the particle at its greatest height is root over 2/5 times of its velocity at half of its greatest height. Find the angle of projection. Okay. Greatest height means maximum height. At maximum height, what is the formula for velocity? Vertical velocity is 0, but horizontal velocity is there, na? What is that? U cos theta. That is equal to given root over 2/5 times of what was given? What was given here? Times of its velocity at half of its greatest height. At half of its greatest height, they are asking what is the velocity of projectile. Okay, the velocity of projectile at half of its greatest height, you can write here in different way. What is the formula you can write for h only? V square minus u square by 2n, and v square means height means only you have to consider sine components here. Okay, now what is the final velocity? What is v square here? At half of its height only, that you have to find out here. Minus initial velocity is u square sin square theta by 2z. Okay, and height should be how much? Half of the original height, na? Total height is u square sin square theta by 2z, but half of the height means 4z. Now you can just solve this. G and G will cancel. Okay, 2 to the cancellate. 2 2z. U square sin square theta by 2 plus the which is the u square sin square theta. That is v square. So if v square sin square theta is common, then u square sin square theta is common, that is 1 plus half, that is 3/2. 3/2 into u square sin square theta equal to v square. Okay, this is the horizontal vertical component of velocity. V you have to write actually here. And then what is v? Root over 3/2 u sin theta. So this is vertical component of velocity after traveling half of the height. And now, what is the horizontal component of velocity? This is vy. It is always same only, no? What is that? U cos theta. Then you just see here, what is the total velocity now? Root over vx square plus vy square. You can just take root over u square cos square theta plus this value also you have to write. Okay, 3/2 u square sin square theta. By substituting here at this point, if you substitute the same equation, Okay, then but just by solving that equation only we'll get the answer. Just try to answer it. And remaining 6 questions are also there. I will just send you the same paper through WhatsApp. You please try to answer the remaining questions. Okay, thank you.